The limit xy tending to 0, 0 on xy square divided by x square plus y square equal to 0. Now here, if x is equal to 0, then there is nothing to prove. And if y is equal to 0, then also there is nothing to prove, right? So here we have to mention that xy cannot be equal to 0. Because if either of them is equal to 0, then there is nothing to prove, right? So fxy be this function with the product xy to be not equal to 0. To show the limit on this to be equal to 0, let epsilon positive be given. And now if I take the mod of f of xy minus 0, because I need to prove the limit on fxy to be 0. So taking the mod of the function minus 0. So this is equal to the mod of, I'm writing this function over here. This is xy square divided by x square plus y square minus 0, right? That is the mod of this function only. So this is further equal to mod of x into y square. There is no need to take the mod on y square divided by x square plus y square. Mod of y square is y square and mod of x square plus y square is also x square plus y square. Now as I know that y square is less than equal to x square plus y square, right? If I take this to the denominator of this, I get y square divided by x square plus y square to be less than equal to 1. So this is less than equal to 1. That means we are getting this further to be less than equal to mod x. Very fine? Yes? Okay. If we choose delta to be equal to, we choose this later, right? Then mod of x is less than delta, mod of y is less than delta, implies what? That mod of f of xy minus 0 is less than equal to, we know that this is less than equal to mod of x, and mod of x is strictly less than delta. Because I need to choose such a delta so that this mod is strictly less than epsilon. So I can straight away choose this delta to be epsilon. Yes, then only I can get this mod to be strictly less than epsilon. So choosing delta to be equal to epsilon, we get the mod of f of xy minus 0 to be strictly less than epsilon. And because but epsilon was arbitrary, so therefore the limit xy tending to 0, 0, I'm using the definition for this, on f of xy is equal to 0. This is what the definition for the limit, which implies the limit xy tending to 0, 0 on writing the function, that is xy square divided by x square plus y square is equal to 0. Okay, thank you.